Alright, we're talking about active transport in this video. Now this video is going to start off with a picture here. Now you see this guy in some kind of ball here rolling down the hill. Now that should instantly bring up the idea of passive transport, right? So this guy, you don't need any energy to roll down the hill. If you wanted to push this ball up the hill, you're going to need a lot of energy, right? So that's what I want you to think about active transport. Now, active transport requires energy, right? Which we know is ATP. So it's movement against the concentration gradient. So if you're moving against the concentration gradient, you are moving from low to high concentration, right? So those particles don't want to be there. They're being forced there through the use of energy. So then there's three different types. We have a pump, which is going to pump things against the concentration gradient using ATP. Then you have endocytosis, which is going to take in a bunch of stuff, endocytosis, with energy. And then you have ectocytosis, which is going to remove a bunch of stuff from the cell, kind of like a bulk sale, so to speak. So in this one, it's the imaginary two boxes, right? The concentration of A is greater than B. Now in active transport, you can actually stuff the rest of these molecules to move to side A and become more concentrated. So think of it this way, right? You have a bunch of dirty clothes here and your parents are about to come in your room. Now you're actually going to use some energy to stuff all of those clothes into one closet and then squeeze the door shut behind it, right? It takes a lot of energy to do that because the amount of dirty clothes in your closet is probably pretty concentrated. All right? So just some definitions. We have the pump, right, which is going to be the movement of a large or charged particle from low concentration to high concentration through a protein channel. So you have a protein channel, that same idea, but this time you're moving it from low concentration to high concentration. And usually the object that you're trying to move is really large or it's charged, right? It's going to have an electrical charge on it. Either way, both of those scenarios, the cell is not going to want it to let it come in through the cell membrane. So if you have a pump here, right, the dots are going to go from low concentration to high concentration. Then you have endocytosis, which is the movement of larger particles into the cell. So let's say there's a bunch of calcium or whatever, what have you, it could be anything, floating outside the cell here. The cell is going to want to get that calcium inside of it, so it's going to use its cell membrane, bend it in, and kind of take it in, almost like the pseudofoot when we talked about the amoeba. So it's going to move its cell membrane, create a nice little vacuole, allow it to enter the cell. Movement of large particles to the outside of the cell is going to be ectocytosis, which is when you have that vacuole and it merges with the cell membrane and releases whatever contents it has to the outside of the cell. Now both these systems are going to be requiring energy, but they should be easy to remember as long as you remember endo represents coming in and exo represents going out. They're kind of like the same process except reverse. Right, so this is just a nice picture of endocytosis. So endocytosis is going to be this nice food particle here, whether that's a big glucose molecule or something larger than that even. It's going to enter, so the cell membrane is going to come in contact with it. The cell membrane is going to kind of engulf it and then pinch off here into a nice food vacuole. This little vacuole is going to fuse with the lysosome, and then the lysosome, the digestion is going to go in here. The whole lysosome right here is going to pop out all of the good stuff, right? All the stuff that it wants into the cell, and then the rest of the particles are going to be considered waste, and then this vacuole right here is going to merge with the cell wall and then spit all of this out, which is what we call ectocytosis. Right, so endocytosis is good stuff coming in, ectocytosis is bad stuff going out. Alright, so the pump is a little bit complicated, so we're going to wait until class to discuss that, but make sure you get notes, and the pump's going to be a huge idea when we talk about cells, especially as you advance into later science courses. But that should be it for this video, short and sweet. Make sure you get the notes down and bring any questions or any confusion you have to class.